looked at length, and the under length we have looked at how we can convert from one unit to another. We also looked at significant figures under length, how we can count the number of significant figures in the number. So today we are going to look at perimeter, which is still under length. The perimeter of a given figure, or perimeter of a given figure, is defined as the total distance around that figure. For the perimeter of a plane is the total length of its boundaries. So perimeter is just the same as length because it is measured in the same units as length. We can look at different shapes to find their perimeters. The different shapes we can have what we call a square, we have a rectangle, we have a circle, and so on and so forth. The square, first of all, is a figure with the all sides equal. It is a four-sided figure whereby all the sides are what? Are the same or are equal. So basically, this is the shape of a square. If you look at that shape, you find that all the sides are equal. So that is how the square looks like. When we talk about the rectangle, this is, first of all, a figure with the opposite parallel sides equal, whereby the sides which are parallel are equal. The opposite parallel sides are equal. And this is how a rectangle looks like. You can see that this side is equal to this side, this side is equal to this side. So you can see that they are all parallel. This side is parallel to this one is parallel to this one. Therefore, they are equal. When we talk about a circle, the circle is roundly shaped. So the circle simply looks like this. That's how it looks like, roundly shaped. So we are starting with what we call a square. Remember, we said the square looks like this. That is having all sides what? Equal. This side is equal to this is equal to this is equal to that. So this is side here, this is a side, this is a side, this is a side, and then this is a side. So there are four sides. And since there are four sides and they are equal, to find their perimeter of the square will be equal by a side plus the other side plus side then plus the side. So you can see that there are four sides there, and the s plus s plus s plus s will get 4s. So the perimeter of the square is equal to by 4s, or 4 times the number of sides which are there. And the units can be in centimeters, can be in meters, can be in kilometers, depending on what they want us to write the units in. That is basically for a square. So we can look at another example. Which says find the perimeter of a square with 5 sides. Find the perimeter of a square with 5 sides. Of a square with each side, equal to 5 centimeters. 85 equal to 5 centimeters. So you can see that we can first of all start by drawing that a square. So you can see that our square is in this form. If that is the square, they are saying 85 side is what? 5 centimeters, meaning that this is 5 centimeters. This one is also 5 centimeters. This is also 5 centimeters. This one 5 centimeters, because for the square, all sides must be equal. Then we can now apply the what? The formula. Our formula will now be perimeter of the square is equal by 4 times the number of sides. 4 times s, where s represents the number of sides. So you can say that each side is equal to what? Is equal to 5. Now, since each side is a 5, we shall say 4 times 5, giving us 20. Giving us what? 20 centimeters. And therefore, the 20 will be equal to the perimeter of that square. Or perimeter will be equal to by side plus side plus side. That is s plus s plus s plus another s, giving us 5 plus 5 plus 5 plus 5. And then that gives us 20 centimeters, because perimeter is the distance around the figure. So basically, that is how we find the perimeter of a square. We can continue. We can look at another example. This is for a rectangle. For a rectangle, still perimeter is given by side plus side plus side plus side. Since perimeter is the total distance around the what? The figure. So we have to add all the sides. The question says find the perimeter of a rectangle whose length is 5 centimeters and width is 3 centimeters. Find perimeter of rectangle whose length is 5 centimeters and width is 3 centimeters. So our solution will be, we can start by drawing the what? The rectangle. So here is how the rectangle looks like. We shall draw it like this. That is how the rectangle looks like. Then we can now put the what? The dimensions. The length is 5 centimeters. The width is 3 centimeters. So remember, perimeter of a rectangle is equal by side plus side plus side plus side, or 2 into length plus width. So in this case, perimeter of the rectangle is obtained by the formula 2 into the length plus width, whereby our length is 5 and then the width is 3. So we shall have 2 into, where there is L, we put 5, where there is W, we put 3. So our perimeter is now equal to by 2 into 5 plus 3, we get what? 8. And the perimeter will now give us 2 times 8, we get 16. The units will be in centimeters. Be in centimeters. Alternatively, or if one cannot be working in that form, since they say it's a perimeter, it's a rectangle, remember it is in that form. This is the 5 centimeters. This is the 3 centimeters. So since the parallel sides are equal, this is also 5 centimeters and this is also 3 centimeters. So perimeter will be equal to by adding everything. So perimeter will be side plus side plus side plus side, which is 5 plus 5 plus 3 plus 3, giving us 5 plus 5, we get 10. Plus 3, we get 13. Plus 3, we get 16. So the answer will be 16 centimeters. So that will be the perimeter of the rectangle. So basically, that's how we find the perimeter of the rectangle. Then we can also look at what we call triangle or triangular shapes. Triangle. How we can find the perimeter of a triangle. First of all, a triangle is a 3-sided figure, or it's a figure with 3 sides. And this is how a triangle looks like. A triangle looks like this. It's a figure with 3 sides. So, to find the perimeter of a triangle, we have to add this side plus this side plus this side. Since there are 3 sides, we add the 3 sides. What we get is what we call the perimeter. To give you more knowledge about triangles, we find that there are different types of triangles. We have what we call right angled triangle, right angled triangle. That one looks like this. That is the type of triangle which has one of the angles equal to 90 degrees. We have another one which is called acute angled triangle. That is a triangle which has each of the sides, each of the angles less than 90 degrees. And this is how it looks like. We have another type of triangle which we call isosceles. Isosceles triangle. This is the type of triangle which has two adjacent sides equal and the two base angles equal. And this is how it looks like. This side is equal to this and this angle is equal to that. We have another one which we call equilateral. Equilateral triangle. The equilateral triangle is that triangle which has all sides equal and all angles equal. This side is equal to this, is equal to this, this angle is equal to this, and is equal to that. So that is how it looks like. We have another type of triangle which is called obtuse angled triangle or obtuse angled triangle. This is the type of triangle which has one of the angles more than 90 degrees but less than 180 degrees. So this is how it looks like. Obtuse angled triangle looks like this. This angle must be more than 90 but less than 180. Then the other one is what we call scalene triangle. This is the type of triangle which has all the angles not equal and all the sides not equal. This is how it looks like. This side is not equal to this and is not equal to this one. This angle is not equal to this and is not equal to this one here. So that is how it looks like. So those are the types of triangles which you must know. However, among all of them, the formula for finding their perimeter is the same. Perimeter of any triangle is obtained by side plus side plus side. We can continue. So, perimeter of triangle is occupied by side plus side plus another side plus another side. Like that. So, given me a triangle, of this shape, assuming we have this triangle, if this side is A, this is B, and then this is C, then perimeter will be equal by A plus B plus C, where A, B, and C are the sides of the triangle. So that is how we find the perimeter of triangle. We can look at another shape which we call the circle. The circle. The circle, in elementary understanding, is just a rounded shaped figure. Any figure that is rounded shaped is said to be a circle. However, the circle can technically be defined as a set of infinite number of lines that are equidistant from the center. This is how we derive the definition of the circle. There are different lines which are equidistant. Equidistant means they are the same distance from the center. So this line here, we find that when we join their extreme ends, we obtain what we call a circle. So therefore, a circle is a set of lines that are equidistant from the center. So, however, if we are to give the right figure or the right diagram of the circle, we find that this is how it looks like. That's how the circle looks like. Rounded, shaped figure. So, we can look at parts of the circle. Now, the circle consists of so many parts as we are going to look at. It consists of what we call circumference, which is circumference is the total distance around the circle. It consists of what we call diameter. The diameter is a line which divides the circle into two equal parts, or the line passing through the center of the circle, dividing it into two. We have what we call the radius. The radius is just a half of the diameter, which is obtained by diameter divided by 2. Then also the circle consists of what we call a chord. The chord is a line which divides the circle into two parts but not equally. It's a line running from one part of the circumference to the other, but not dividing the circle into two equal parts. Then it has what we call the segment. The segment is formed by a chord. When you draw a chord, you find that you form some segments. These segments we may have what we call minor segment and then what we call the major segment. But it also has what we call a sector. The sector is formed as a result of drawing lines in a circle, say for example running a line running from the circumference to the center, then also from the center to the circumference, forming what we call a sector. So basically these are some of the parts of the circle. So we can illustrate these parts in a circle as we are going to see. So assuming this is our circle, if this is the circle, we are saying in a circle we have what we call a chord. This is what we call a chord. The chord is the line that divides the circle into two parts, but not equally, running from one part of the circumference to the other. Then, this is what we call the center of the circle. In the center of the circle, we have a line that passes through it, dividing the circle into two equal parts. And the line is what we call the diameter. Also, a line now drawn from the center of the circle to the circumference is what is referred to as the radius. The radius is a half of the diameter. So this is what we call the radius. Now, this radius here meets the center at an angle, forming what we call a sector. This part here is what we call a sector. It is just a proportion of the part formed in a circle, which is what is referred to as a sector. And the sector forms an angle here. Then we also have what we call a segment. We find that if this is the chord divides the circle into what we call segments. This is part what is referred to as the segment. So this is minor segment or small segment of the circle. Then the remaining part, all of this is what is referred to as the major segment. Which is formed by the whole of the circle. So basically, these are the parts of the circle. The total distance around the circle is what is referred to as the circumference. Now, part of the circumference of the circle is what is called the arc. We call it the arc. So the arc is just part of the circumference of the circle. So let us look at the circumference of the circle. The circumference of the circle. First of all, circumference of the circle is the total distance around the circle. Another name for the circumference of the circle is the perimeter of the circle. And the circumference of the circle is given by the formula 2 pi r, where r represents the radius. Pi is equal to 22 over 7. However, when we are given a diameter, when we are given diameter of the circle, that if this is the circle and this is the diameter, then the circumference of this circle will be equal to by pi d. That is pi times the diameter times the diameter. For the radius, circumference is equal to pi r. So let us look at a practical example on how we can calculate the circumference of a circle. We can have an example here, which says that find the circumference of the circle of radius 7 centimeters. Radius 7 centimeters. So if this is the circle, and the distance from the center to the circumference here is 7 centimeters, which is the radius, and they want us to find the circumference. So circumference is equal to by 2 pi r, where pi is 22 over 7. So circumference will now be equal to 2 times pi, which is 22 over 7, then times r, which is equal to 7. Automatically, the 7 will cancel with the 7, and our circumference will be 2 times 22, giving us 4 centimeters. So the value of the circumference becomes 44 centimeters. We can look at another example. Example number 2 says the circumference of a bicycle wheel is 144 centimeters. The circumference is equal to 140 centimeters. 140 centimeters. Find its radius. Radius is equal to, we don't know. So to find the radius, what do? We apply the same formula. So we know that circumference is equal to 2 pi r. But they have given us circumference as being equal to 140. So we shall get to 140, which is there, is equal to 2 times pi, which is 22 over 7, then times the radius, which we don't know. So in this case, 140 will equal to 2 times 22 is 44, then times r, you get 44r all over 7. I will multiply here by 7, and then this side by 7. The 7 will cancel the 7, and we shall now be left with 44 r is equal to 7 times 140. 7 times 100 what? 40. So we find that 7 times 140 is equal to 140 times 7, we get 980. 980. To remain with the r, I divide both sides by 44, here also by 44. So that our r will give us 980 divided by 44. You find that we get 22.27. 22.27. Such that r will approximately equal to 22.3 to 1 degree. When rounded off to one place of decimal, we find that the radius of the circle is 22.3 centimeters. So basically, that is how we find the circumference of the circle, the radius of the circle, and so on. We can now look at the length of an arc. We said that the arc, first of all, is a part of the circumference. Part of the circumference is what we refer as the arc. So we want to see how we can find the length of an arc. Length of an arc. How do we form the arc? That is, when we have a circle like this, and then we have a radius here, and then another one here. This part of the circumference is what is referred to as an arc. This is an arc. So in this case, there is another part also which is this. So since it is a part here is small, we shall call it the minor arc. Then this becomes the major arc. Now, how do we find the length of the arc? For example, from point A to point B. Point A to point B. To find the length of that arc, the formula is length of the arc is given by the formula length of the arc is given by the formula angle out of 360 times 2 pi r, whereby that angle We can represent it by letter theta out of 360 times 2 by r. So r over 360 times 2 by r is equal to the length of the arc. So we can use this formula to find the length of the arc. We can look at an example on how we can apply the formula. The question says, an arc of a circle subtends an angle 60 degrees at the center of the circle. Find the length of the arc if the radius of the circle is 42 centimeters. In brackets, take pi as 22/7. So we can analyze the question. The question says, an arc of a circle subtends an angle 60 degrees. It means our angle theta is equal to 60 degrees. 60 degrees. At the center of the circle. Find the length of the arc. Length of the arc, which I can represent as L is equal to, you don't know. Whose radius is 42? Radius R is equal to 42 centimeters. So they want us to take pi as 22/7. So we have better analyzed the equation and put it in short form. So remember our formula is the length of the arc is obtained by the formula angle, which is 360, angle theta out of 360 times 2 by r. Then we substitute. We shall find that our length m is equal to theta, which is 60, out of 360 times 2 pi r times 2 times pi, which is 22/7, then times r, which is equal to 42. So here we shall find that by 7 once, 42 divided by 7, we get 6. By this 0 will cancel with this. By 6 once, 36 by 6, we get 6. By 2 once, 6 by 2, 3. So that will now get our length of the arc will equal to 1 times 22 times 6. So we shall have 22 times 6, which is 12 here, we carry 1, 13 out of 3. So our N will equal to 132/3. And 132 divided by 3, we shall have, first of all, 13 divided by 3 goes 4 times. Remember 1. That 1, we put it here to make it 12. 12 divided by 3 gives us 4. So therefore, length of the arc will now equal to 44 centimeters. That is how we find the length of an arc. We look at example 2 on how to find the length of an arc, which says the length of an arc of a circle is 62.8 centimeters. Find the radius of the circle if the arc subtends an angle of 144 at the center. We look at example 2. We are saying the length of an arc of the circle is 62.8. So our L is equal to 62.8 centimeters. Find the radius of the circle. Radius of the circle we don't know. Find the radius of the circle. If the arc subtends an angle of 144 at the center. So our angle theta is 144 degrees. Take pi as 3.14. Pi is equal to 3.14. Right. So here the formula is the same. We know that the length of an arc is given by theta out of 360 times 4 pi r. Then we carry out substitution. But they have given us L. So when there is L, we shall put 62.8. Is equal to theta, which is 144 out of 360, then times 2 times pi, which is 3.14, then times r, which we want to find the radius, r. Simplifying 62.8 will equal to, so we are going to multiply 144 times 2 times 3.14. So we get 144 times 2 times 3.14. We get 904. 904.32 r, 4/360. So when we cross multiply, we shall find that 1 times 904.32, we get 904.32 r, which is equal to 62.8 times 62.8 times 360. You find that we get 22,608. Remain with the r, I divide both sides by 904.32, hereby 904.32. So that this one's automatically cancelled. We shall be left with the r, which is equal to this one divided by 904.32. We find that we get 25. So therefore, the radius of the circle will equal 25 centimeters. So that one will be the answer. The last example says, find the angle subtended at the center of the circle. Our angle, you don't know it. Theta is equal to, we don't know, by the angle subtended at the center of a circle by an arc of length 11 centimeters. Length is equal to 11 centimeters. If the radius of the circle is 21 centimeters, radius 21 centimeters. So here the formula is also the same. We know that the length L is equal to theta over 360 times 2 by R. Then we substitute where there is L, we put 11 is equal to theta. Theta, we don't know it, we leave it as it is, over 360 times 2 times pi, which is 3.14, then times the radius, which is 21. In this case, let us use this one as 22 over 7. 22 over 7. So you can see that the 7 will cancel. 21 divided by 7, you get 3. So we shall now have 11 is equal to 2 times 22 times 3 times theta. 2 times 22, you get 44. 44. And 44 times 3. We find that we get 132. So we get 132 theta all over 360. When we cross multiply, we find that 1 times 132, we get 132 theta, which is equal to 11 times 360. 11 times 360. We made the theta, I divide both sides by 132. Is equal to 11 times 360 out of 132. This will cancel and we shall be left with 11 times 360. We find that we get 360 times 11, we get 3,960. 3,960 out of 132. And the figure will now give us, when we divide 3,960 by 132, we find that we get 30. 30. And the angle is measured in what we call degrees. So we have to put that small circle on top of 30. So therefore, we conclude by saying that the angle subtended, therefore, angle subtended will equal to 30 degrees. So that is how we work it out. So this has marked the end of the perimeters.